I considered the book Rafiqul Jaman, most of the part. Okay. So last class, I have explained that little bit of your design. What has happened? Just a minute. Now, what has happened? We have. What is the problem is going on? See that we have, suppose, one processor or CPU, whatever it is. It has some address buses. You know that CPU also has some address buses, some data buses, some control signals. Already when I have explained your 8085 processors and programming part, there you have seen some signals are available for address, some signals are available for data bus, some signals are available for controlling. Okay, so suppose that you have the addresses A0 to A, for example, 8085, then A50. So what are the memory addresses it can use? So, or you can say that what is the address space? Okay, so it start from 0000. If I consider the hexadecimal number, then it can continue up to FH, isn't it? So these are the address space the processor can utilize, because it has maximum address bits, that is a maximum address lines, that is a 60, not more than that. What has happened in our computer system? We have ROM, we have RAM, we have different IO devices. So what has happened for whole address space we do not use for designing the memory. What we will do, some part of the memory, sorry, some part of the address space, not the memory, I am telling, memory, that means it is possible from 00H to FFH, but never we try to use the whole address space for designing the memory. Some part of this address space, for suppose 0000H to FFH, that we use for the ROM. Some part of the address space we use for the RAM, some address space we use for designing the ports, different type of the ports for addressing the IO devices. Okay, so what has happened in the market? We have different smaller size of the memory. We do not we have the different sizes, but big memory we never considered, or you can say that depends on our requirement, we can interconnect a different smaller size of the memory. That type of the designing concept is called the memory array design. Clear? So address space that that we can have with the help of CPU. Whole address space never we use to designing the memory. Some part we use for memory, some part we can use for other purposes. Other purposes means that for designing the port address. This is also address, but for the port address for other devices which you need in your computer system. Now for memory design, what has happened? Your requirement is m by n, and you have the small m by n. On that moment, you can compute the number of ICs that you want to interconnect. Okay, and this value k, sometimes it will be rounded value, that is the whole number, and sometimes it may not. So it doesn't worry about it. Whatever the value, just you round the value. Okay, in that way you can compute the your you can say that uh, you can use for your system. Okay. Okay, Now, this is known to you. This is known to you that 2 to the power n into m, this is the size of your RAM, because A0 to n minus 1. So total address bit is n, total data bits are the m. So size you can compute with the help of this address and data lines, and that is 2 to the power n into m. Now I have taken one example here. Consider a system in which the available 64, we actually we want this, okay, but we have this two IC, okay. With the help of these two IC, we want to design 64 KB memory. Now for the design, we should go step by step. First is that what is our requirement. We try to understand that the memory which we need, how many address bits and how many data bits are required. Now 64 KB if we need, that means ultimately we have the 16-bit address bus and 8-bit data bus. KB, B for the byte. So I assume here the 8-bit is a word for the memory. Word size is the 8. Each word can store 8-bit data. Now 64, that means 2 to the power 16. So obviously it has the 16-bit address bus. Now if we start from A0, so n will be A15. Now this is the our requirement. But what we have 32 KB EEPROM and 32 KB RAM. EEPROM is the ROM, one type of the ROM. You have the different types. I'm not going the technology of the different type of the EEPROM or ROM. Please you study yourself. But whatever it is, I just want to understand the size. What is the size? Now 32 KB, that size we can write 2 to the power 15 into 8. Okay. So I assume here, one thing I have assumed, that is not given in my question, that what is the word size. I assume here word size is 8. If word size is 8, on that moment, we can consider the 15 address lines. So 15 address lines means that if we start from A0, then we will end A14. Okay. And if we assume the 8-bit data bus, we can start from D0 and we can, sorry, this is not the DA, this is a only D7. Okay. So obviously 32 KB plus 32 KB, we can have the 64 KB memory. Now how we can design? First, I have written what is our requirement. Our requirement is that 64 KB. So for that reason, we have the address bus. We have to have the address bus, that is A0 to A15. But we have the memory chips. They have the address lines from A0 to A14. So all this memory, that 32 KB RAM or ROM, whatever it is, it can start from all 0, then 1, 2, 3, in that way. Ultimately, all will be the all ones. This is the starting address, you can say, and this is the ending address. And this range, it will be, if a processor can use when that A15 is 0. What is the meaning? If A15 is 0, on that moment, chip 0 will be selected. That means first chip will be selected. And again, for the second chip, that starting address will be all 0 and then all will be 1. But A15 will be 1 on that moment. So with the help of A15, we can select first chip or the second chip. If it is A15 is 0, then chip select the first, suppose it is, we consider, and it is a, if we consider CS2, and we know that it is a complement to select. So when A15 is 0, on that way it will be 0 and it will be 1. When A15 is 1, on that moment CS1 will be 1 and it will be 0. So you can understand that at a time one chip will be selected. At a time both the IC will not be selected here. Okay. So with the help of A15, we can select the chip. Okay. Now if we consider in this fashion, what will be the memory address range. What will be the memory address range? Now see that for a single chip, the this A15 is constant. Okay, and for the second chip also A15 is constant. Now if we consider the first chip, on that moment starting address will be all 0, that means 0000H, and after that all will be 1 except A15, because A15 you do not have in your memory chip. Okay, so for that reason you cannot consider here 0, that will be remain constant. So for that reason 0 1 1 1, that means this is the 7, and obviously these are the F, so 7 FFH. Now for the second chip, what is happen, your A15 is 1, on that moment your CS2 will be 0. So this second chip will be selected. A starting address will be 1000, that means 8, all are 0, so 800H, and all will be 1. So A0 to A14 will be 1, all will be 1. On that moment, what will be happen? 1 1 1 1, that means F, all are 1, so obviously all will be the FFH. Now if you see the circuit, then you can understand better. So our target was 64 KB, so address we need that is a A0 to A15. Okay, so see that we have A0 to A14 and A15. A15 is used to select the chip 0 and chip 1, and this memory which you have, they have the address lines, that is the 15 address lines they have. So for that reason you have here A0 to A14, A0 to A14. Okay, so A0 to A14 you can connect to this two memory chip, and these two are the address lines that are the 8 bits. So 8 bit you can connect through this data buses, and here A15 is used for selecting the EEPROM. And you can ask one question maybe, that is, ma'am, from where we will have this. Actually here we have the processor. Okay, from that processor has address lines, so address line is connected to here, and it has the address lines also connected. A few lines are connected to the memory, and few lines are connected to control the memory, or for selecting the memory chip. So in this way we can design the circuit. Better, you have any question after this? You have any question, better?
One doubt, ma'am. One doubt, ma'am.
Any question, better?
Ma'am, I have one doubt, ma'am.
Bolo?
Ma'am, in the second chip, ma'am, why is the address starting from 8,000?
Yeah, because I have considered the hexadecimal number, better. Huh? Here I have considered the hexadecimal number. Hexadecimal number, suppose it is a 80, so 0 represent, that is 0000, 8 represent, that is 1000. Understood that? So one digit represent, we can represent with the help of 4-bit binary pattern. Now this address is the it is your requirement. Okay, but you have the IC which has the address lines from A0 to A14. So after A14 it can change from 0 to 1. Clear? And here for the chip 0, A15 is used for the selecting that chip. So that's why for a particular chip you cannot change the value of A15. A15 will be remain same for the chip 0, that is 00. But A0 to A14, that you can change. See that here the circuit, these lines are connected directly to the RAM chip or ROM chip. Okay, so this may be from 00 to 00, so 00, all zeros to all 1 you can have. See that, that's why I have considered that this is the starting address. This is the starting address. Okay, and this is your end address. See this chip, it can we can use from 000H to 7FFFH. This address range we can use for the chip 0. But for the chip 1, on that moment 15 we have considered the value 1. So if we consider the value 1, so this is the 8 1000, that meaning is that 8, and these are the 0. In that way, we have the 80008. This is the starting address beta. For the chip 1, this is the starting address and this is the ending address. So this range we can consider for your chip 1. And 8 represent, that is A15 is 1. For that reason we have the 1, and obviously starting address is all are 0. Okay, for any chip we can say the starting address is all zeros and ending address will be all 1. So for that reason we have the 80008, and here 1111 is the last for the last address, so that's why it has the F8. Now it is clear better.
Yes, ma'am.
Yeah, so you have to compute the addresses. Okay, so sometimes it may be happen, I can give some address range, based on that you have to design. So from the address range you can compute the total address, total address, or you can say the total data you can store. From that, reversely you can compute the number of memory chips and you can design the circuit. Okay, here what I have done, we have considered the total address space what we have, what we need. Based on that we can design the circuit, and after designing the circuit we can find out the address range. So in reverse way we can do this. Okay, now another example, same way we can compute or we can design. So our requirement is 32 kb by 8, but we have the 8k by 8. Now obviously if we divide, then we can have the 4. So that 4 I assume two ROM chip and 2 RAM chip. With the help of this I want to design. Now what is our requirement? Target is that to design the 32k by 8. Okay, here the word size already is given. Word size means that how many bits you can consider in your data bus. So 8-bit your data bus, and 32 KB, that means 2 to the power 15. So 15 address lines. So our target is that to have one memory which should have the address lines from A0 to A14. So obviously that can have the address range if it is the starting address is 008. Okay, if I consider the starting address 00008, on that moment ending address will be 7FFH. If we consider the different, on that moment, based on that we have to compute the based on the starting address and based on the capacity or size of the memory, we can compute the end address. Okay, so if we start from 00008, then it can complete the 7FFFH. Okay, now what we have now, that is a 8k by 8 memory we have. So 8k by 8 means that 8 data lines, and 13 we have the address lines. So here after 13 means that A0 to A12. Okay, A0 to A12 we have, and data bits are the 8 bits. So 8 data lines we can consider D0 to D7. Sorry, beta, I have copy paste sometimes. That's why this should be D7. Now same way we can do this thing. See that after 812, that means 13-bit we have. Okay, this is this we have, and our target is to design this address range. Okay, the address range which may need the address lines from A0 to A14. See that 7FFH, this is the all one. So 7FFH if we want to have, so on that moment we need the 15 bits. So for that reason that will be A0 to A14. Now here after A12 we have, and remaining 2 we can use for your selection of chip. Okay, so when A14 and A13 is 00, on that means chip 0. When 01 chip 1, 10 for chip 2, 11 for chip 3. So you can understand that why we need the decoder circuit. So this A14 and A13 we can give the input to the decoder circuit, and from that we have the four output lines and all one line for selection one chip. So 4 output lines, so 4 chip we can select. Okay, but if we consider only a single chip, on that moment starting address will be all 0 to all 1. this will be remain constant. 0 0, it will be also 0 0. So for that reason, what will be happen? These are the F, these are the F, and also it is F, and ultimately here it is suppose if 15, then you have the 0 0 0 1. Okay, so 0 0 0 1. So you have the value 1. So in this way, I just compute the corresponding hexadecimal number. All are hexa. Okay, all are the hexadecimal number. So if it is for the chip 1, starting address is all 0, and it is a chip select. Chip will be selected with the help of 14 and 13 0 1. So 0 for 0 1 pattern you have to consider here. So if you consider on that moment 0 0 1 1, so that is the 3 and 3 FFH. And same as for chip 2, 4008, then 5 FFH, 6008, then 7 FFH. Okay, in that way we can compute the address range of all the memory. Okay, now
Ma'am, could you
so
go to the
these
previous
are the
slide once,
address
ma'am?
ranges.
Ma'am, could you go to the previous slide once, ma'am? Like the where you solved that 32 KB into 8 one. Before that, ma'am, before this slide one. Yes, ma'am.
Yeah.
Ma'am, over here, acha, number of data, acha, D0 to D7. Okay, thank you, ma'am. Thank you, ma'am.
Okay. Now see the diagram. This is the decoder circuit, and A13 and A14 we use for the inputs, and obviously this is the MSB beta, and this is the enable line, and just you can give the ground value or logic 0 value you can give here. And already I have explained the function of decoder circuit. This is the active low output lines. All of the active low output lines we have considered. This type of decoder we have considered because we want to select some memories, and for the selection of the memories we use the pin, that is CS bar. That is CS bar is one of the control signal we use, and this is, if it is 0, on that moment it will be enable. Okay, so for that reason we use the active low output decoder circuit. Now see that for 8K by 8 we have the 8 means that 2 to the power 3. So that means 2 to the power 13. That means A0 to A12. So we have the 13. All are the 13 bits. Okay. And we have the 8 bits for your data bus. So this is the data bus. Directly you can connect, because you have the 8-bit data bus. So directly you can connect to the data bus with the memory. These are the data bus of your memory, and this is the data bus of your, you can say, system data bus, or you can say that that bus will come from a processor or may come from other devices. But whatever it is, if it is dedicated for this system bus is dedicated for the data bus, which on that moment we can connect to all the memories. Okay, because all memories have the that is the 8-bit 8 data lines, so we can connect this. So first you understand that what are the lines you have for your RAM. Okay, RAM or ROM. So RAM, you have the address lines, data lines. So connect address lines. What are the available? Availability is the 13. So you can connect A0 to 12. You cannot connect A0 to A13 because 13 is not available. Address bus is available, that is A0 to A12. So here you have the A0 to A12 13. Here you have maybe 13, 14, 15, maybe you have many, but for out of this you need only two, that is the 13 and 14 to select your decoder. And suppose that if you need more than that, on that moment all other lines, suppose you have the 16 address lines, so on that moment you also have the 13, 14 and 15. So on that one 13, 14 you can use for the input of your 13 and 14 you can use for input of your decoder, and other lines you can use for your enable the decoder. Okay, so sometimes maybe happen I take more than line, suppose that A16 is also available. So what are the remaining pins? A0 to A12 you can directly connect, but in your system you have more than that bus. That means you have the A13, A14, A15 and A16. On that moment, how many chips you are required? That is 4 chips are required. So for the 4 chips only 2 lines are sufficient to select the memory. because it can give the combination of 0, 0, 0, 1, 1, 0, 1, 1. So 4 combinations are unique combinations we have. With the help of that, we can select the 4 RAM chip. But other lines, whatever the other lines you have, that you can combine to select or to enable the decoder. Here, I don't have any I have not considered any other address lines. That's why I have given here logic 0. But suppose if you have the lines 15 and 16, you can combine these two. Now this 15 and 16, how you can combine? So that basically, if we don't need that thing, we consider the 0, 0. Okay, so for 0, 0, you can give both are 0 on that moment 0. So you can use a 1 OR gate from these two lines, A15 and A16, and this output line you can use to select the decoder circuit. Okay, this is little bit complicated. I'll not give this type of problem. Whatever the required design, based on that you have to find out the address lines and only consider that number of address lines. Clear? And on that basis you have to design. Now I hope you understand this circuit. Clear better?
Yes, ma'am.
Okay, wait. কোথায় চলে গেলাম? Okay, another type of design, that is the here data bit is 4 bit. Okay, we have different ICs with this configuration, but here the data bits are the 4 bit, and address bits we have considered the 10, that is A0 to A9. Now suppose that we want to design with the help of that, that is a 1K by 8. That means address, whatever the address lines, the address space, you can see that that is remaining same, but data bits are expanded. That is a you have in your available chip, that is a 4 bit, but you have to design up to 8 bit. That means this 0 to D8 you have to design. Okay, now if you compute the number of ICs, so you need to design 1K by 8, and in your IC you have 1K by 4. So obviously you need the two number of chips. Here I have done the same way, that is a data bits are the 4. What I have done? Yeah, 1K by 4 have 4. I have done something wrong better here. That should be
Ma'am, are you saying something?
D0 to D3. Okay, so here we do not use
Ma'am,
any.
you're not, ma'am, you were not audible all this time, ma'am, because I don't know why your screen had gone black and your voice is not audible, ma'am.
Okay, just wait better. Just wait. Now am I audible better?
Yes, ma'am.
Hello? Screen is visible?
Yes, ma'am.
Okay. So here
Ma'am,
See
we were
that
at the
at
previous
this
slide,
stage,
ma'am. When you stopped getting to listen to you, ma'am.
what happened, beta?
Ma'am, we were at the previous slide when we stopped like hearing you, ma'am.
Now, am I audible, beta?
Yes, ma'am. Now you're audible, ma'am.
Okay. You can see my screen, PPT.
No, ma'am, it's not visible, ma'am. You haven't presented, I guess, yet.
Now it is visible, beta.
Yes, ma'am. Now it's visible, ma'am.
Okay. So last question was that desired 1K by 8 using 1K by 4. See that the 1K that is a mm, that is the same, address space is same, okay, but data bits are different. Total we can have the 8 bit, okay. So for that reason we need the 2 chip, okay. Now same way we can design. This is the, see that the address space is the same for chip 0 and chip 1. No line is required to select the ICs, and one IC used for the D0 to D3, another IC is required for D4 to D7 because we need the
Ma'am, you're not audible again, ma'am.
now. Am I audible, beta? You have problem. Sorry for that.
Now you're audible, ma'am.
I'm sorry, beta. Now I most of the part I have completed. Just you see that I have given more
Ma'am,
examples.
hello, ma'am.
हाँ
I have a question, ma'am.
हाँ बेटा.
Can we do 8-bit data bus by 3-bit?
I can't follow your question again. You tell me, beta. Due to network problem, I can't understand what you have told.
Ma'am, can we decode 8-bit data by 3-bit?
by 3-bit data bus, isn't it?
Yes, ma'am.
Yes, you can do. It's not a big problem because on that moment you need the three ICs, 3 plus 3 plus 3, because 3 plus 3, that is a 6-bit you have, but you don't have the 8 bits. So more for that you need another. But what happened, we always use the 2 to the power something, okay, whatever the available memory we have in our market, most of that we that is a 2 to the power something. In that way they are designing, and processor also has that type of the memory, but sorry, that type of the data buses. So always whenever design or fabricate any IC, they always try to maintain some compatibility. Okay, so because everything is designed or fabricated based on some future purpose. So availability of the IC, whatever you have in the market, most of them you can have the 4-bit, 8-bit, 16-bit, 32-bit, 64-bit. In that way you can have the data bits. Okay, so on that moment we can use, but it is possible if you have, theoretically you can design. So on that moment what will be happen, for the first bit, first IC we have the D0 to D2, and second IC you have the D3 to, in that way, and last what you have only one bit, that means D0 to D5, D6 you can use, D6, sorry, D0, D1, D2, D3, D4, D5, D6, D7 you can use, and D8 on that moment always you use the logic value 0. In that fashion you can use, no problem. Clear?
Ma'am, one confusion. 1K into 4 RAM, we are using 8 bits for address and we are using 4 for data. Why?
What is your question, beta? 4 data, because it is a D, we need the 8-bit. For that reason 4 we have used.
Okay.
Okay, because our target is to have the, because if processor sends the 8-bit data, how it can store in the memory? So if we use the microprocessor, suppose I draw the figure, this is your, sorry, suppose you have, because whatever you design based on your microprocessor basically. Okay, so suppose you have a processor, you have the 8-bit your data bus 1 2 3 4 5 6 7 8. On that moment, for the chip 1, or for first memory, okay, so for the first memory, this this memory has only the 4 lines for your data, so 4 lines you connect here. Another IC, that is supposed to, so another 4 lines you can connect here. See that here chips has the each chip has the four lines, it is also 4 lines, but processor can select simultaneously this two chip, and lower 4-bit can store in the chip 1 and upper 4-bit can store into the chip 2. Okay, in that fashion if we design, so easily we can, or you can say that CPU can directly transfer the 8-bit, but at a time both should be synchronized. Chip 1, chip 2, at the same time they will be selected, they will be enabled. On that moment, if processor transfer the 8-bit to the memory, on that moment that
Ma'am, you are not audible now.
Ma'am, you're not audible again, ma'am.
Better today I don't want to continue this class because I have some problem. Monday I will take your class. Okay. Am I audible?
Yes, ma'am.
Okay, ma'am.
Okay. Thank you, ma'am.
Okay, and I'll give you one assignment. Okay, I will upload this PPT, and please try to solve that assignment. I hope you
Ma'am,
can do yourself.
ma'am, can we solve it next week, ma'am? Because this week we are having exams, ma'am.
Okay, I have given very small number of problems. Only 3 problems I have given. If you can understand, if you try, maybe you cannot design. Okay, no need to submit. You try first.
Okay,
Then you
ma'am.
can understand the
And ma'am,
design.
will the notes you will upload, ma'am, will they have both sets of memory management, like the last one we did last class
Yeah,
and the one we did today
yeah.
also?
Both the thing I will upload it today.
Okay, thank you.
Okay,
Thank
and
you.
this assignment you will try. Maybe you cannot solve, but you will try. Then you can understand my lecture next class very well. Okay, beta. Sorry.
Okay, ma'am.
Thank you, ma'am.
Okay, beta.